Good afternoon, folks. Welcome to another Lunch and Learn from CAD Dimensions. I'm Kevin Holbrook, part of our technical staff here at CAD Dimensions. Our topic today actually came about because of some of the changes in the SolidWorks product lineup. We'll talk a little bit about that, but we want to talk specifically about circuit boards and utilizing them inside of SolidWorks. You know, how we might design a circuit board, communicate it with folks within the organization doing ECAD work, specifically in a program for electronical CAD. We'll talk a little bit about the different types of programs that are used in that arena, but talk about how we can get SolidWorks involved with that group and communicate back and forth. So our agenda today is first, a little bit about why to link the two. I think it's fairly obvious, but for those of you who are not familiar with the relationship, the typical relationship inside organizations between mechanical CAD and electrical CAD work, we'll talk a little bit about that. Talk a little bit about how we link the two systems together. It really comes down to, in a lot of cases, the file formats that are used, and then I'm going to demonstrate a couple different products that you're going to have available to you, and everybody on the line will have some availability of SolidWorks, and I'll talk about that. And I want to talk about what I'm just calling the future of ECAD MK. It's actually, you know, several years old now, but the technology is really taken off, and some of the things that we're able to do. And I have a video of an integration between an ECAD and SolidWorks, and I wanted to show you that to kind of close out today. So first of all, why do the linking? In my travels, seeing a lot of our customers and looking at the way that they're built, and how you have mechanical groups and electrical groups that are, I would say, somewhat segregated within an organization. I think there is some handshakes when you do have circuit boards that get added to product. There is a relationship there, but it's not as strong a communication relationship as it possibly could be. And that's why SolidWorks has, for quite a while now, had CircuitWorks to give a little bit closer integration between the two groups. In a general sense, you know, why do you want to have accurate circuit board models in your mechanical design? Besides the obvious, will it fit? Am I going to have collisions? I look at the largest component. Is it, how far away from other components in my assembly is it going to be? Understanding the position of those components. It gives you a much more accurate design, allows you to design the packaging around it much better, create better products in that sense. But some things that you don't think of that maybe could be useful down the line is, you know, maybe utilizing, once you have that board inside the SolidWorks model, utilizing it for thermal analysis or electromagnetics. There's third-party programs that go inside of SolidWorks that will do electromagnetic analysis as well. And then on the sales side of your business, maybe PhotoWorks, rendering them. You know, just giving a more accurate look at your design, or using it in Composer and so on. Now, the benefits for the electrical design is the mechanical group can create more complex board shapes inside of SolidWorks and then transfer them to the ECAD group. And now our whole conversation started out with this communication. And I would say that in a lot of organizations, even the board design gets started out in the electrical group. Here's where you could create a complex board shape inside of SolidWorks and transfer it to ECAD using CircuitWorks. And I'll talk more about that and actually show you how you could go ahead and do that. In SolidWorks, a mechanical user can also define things like keep in and keep out areas, so that the electrical group knows that I need to keep components away from this area. Maybe I have an LCD screen sitting there, or I have something else within my design that it's going to require me to keep components out of the way, I can dictate that at the initial board level, which I'm going to show as well. Now, how can ECAD and MCAD be linked? Well, this conversation's kind of changed over the years. Initially, we were talking about a format called IDF, and there's multiple flavors of IDF. Some have been more popularized in the ECAD industry. More specifically, version 2 and version 3 were widely adopted by many programs. Version 4 came out, and it's kind of taken a little longer to be adopted, but we use this neutral format. It's like a step or an IGES file. We use it to communicate between ECAD and MCAD. Okay, a little bit later on, I'm going to show you another format that's kind of taken prevalence lately, but IDF is still the main or the industry standard ECAD MCAD translation tool. Things to think about with that: when you have IDF version 2 and version 3, there's actually 2 files for each version. It's like a part of an assembly. You have 2 files that you have to deal with. When they went to version 4, it's one single file with a different extension, so it does change a little bit. Now, the real important part is who supports IDF, because there's a lot of players in the ECAD industry, and just about all of them have IDF output from their programs. The IDF format support in SolidWorks, and I'll show more of these products as I go through the Lunch and Learn today. But the support started on the SolidWorks end around 2005 with a Lite version, and then in 2008 we got the full-blown SolidWorks version. And then the change which really brought about today's webinar is the fact that full-blown SolidWorks is now included in professional seats. It used to be part of premium only from 2008 to 2014. It's now included in professionals. So for those of you who thought that maybe this product was out of reach previously, you will have access to this product, and as I demo it through, you'll see what you have. Let's talk about the first product, and that's the product that everybody has access to, and I would say less than 5% of our users really know that they have this capability out of the box in standard SolidWorks. So standard SolidWorks includes a product called SolidWorks Lite. Now, SolidWorks Lite allows you to take an IDF file, bring it in, and create the circuit board. It is very easy to use, very simple, very little interaction required. Some disadvantages that I have listed here: it doesn't support IDF 4. It only does 2 and 3. You can't save the models back to IDF if you're trying to communicate back with the group. It's limited in the types of things that it can bring in, and it struggles with large PCBs. It really only has a 500 component maximum. But I wanted to give you an idea of how to use SolidWorks Lite here today, just so you can get a sense of what the capabilities are. So inside of SolidWorks, just in the File Open dialog, typically users will have it set to part or assembly or whatever. But you probably did not notice at the very bottom of the File Open dialog is the ability to open IDF. Now, this is included by default. If I select that IDF file format, I can then come in there and grab the file. Notice the file extensions. These are the ones tied to IDF version 2 and version 3. So this is a circuit board design coming from an existing ECAD system. Now, when I open it up, it's going to give me an important message here. It says, hey, you know what? This copy of SolidWorks has a full version of SolidWorks. You can get better performance. It's going to do more things for you. Do you will still want to process this with SolidWorks Lite? I can tell it not to remind me again, but I'm going to process this with SolidWorks Lite. You'll notice that it will go through the IDF file completely and import and create a board. I want to talk about some of the things to think about with SolidWorks Lite. Yes, I get a board that's brought into SolidWorks. It's a single part file, so notice the file name example 1. It has 21 bodies. Each component shows up as a separate body. It does very nicely bring in the component names from the IDF file. As far as the board goes, it doesn't bring in all the extras like plated holes, non-plated holes, vias, trace paths, that kind of stuff. That's not brought in with SolidWorks Lite. This can be put into an assembly. Where you kind of lose some of the visibility and where a lot of organizations want to go is to get a full bill of materials, including the bill of materials of a board itself. So this makes it a little bit harder because you don't have the control over all the property information, having all the layers of the board, some of the things that you might need along the way. On top of this, we talked a little bit about when I introduced SolidWorks Lite that it was, once you get over 500 components, it gets a little bit slower. That's because each time you open an IDF file using SolidWorks Lite, it recreates the component. And I'll talk about how that differs from full-blown SolidWorks here in just a moment. So, you have this capability today to go ahead and bring in an IDF file. Just, find one on the web, go to your ECAD group and grab one and see what it looks like, okay? But I want to kind of take us through the full-blown product. So SolidWorks, now included in SolidWorks Professional, produces a SolidWorks assembly from the IDF file. So the assembly, the advantage of that is that each component is an individual file that can show up on the bill of materials, makes it a lot easier to include or exclude from the bill of materials. It also builds a library of components. So as you start bringing in boards, and boards have part numbers and reference designators, it actually builds a component library. And as you bring in more and more boards, it doesn't have to rebuild the components completely. It's just going to go to this library and say, oh, do I have this capacitor in there? Okay, let me grab it. It makes things a lot faster, and it gives you some flexibility. It supports all the information that you would expect in an IDF file or a PADS ASCII file. So it has support beyond just IDF2 and IDF3. There's PADS, and there's a format called ProStep, which we're going to talk a little bit later. But it supports cutouts, keep out areas, vias and trace paths and layers and all these things that you would expect coming from the board itself. Really the only disadvantage that it has is that you have to have professional to be able to get access to it. So let's take a look at how we would use full-blown SolidWorks. Okay. Now SolidWorks gets turned on as an add-in inside of the SolidWorks add-ins. You can see that I do have mine turned on. Once it's turned on, and I don't know if you noticed this change in the 2015 release, they've moved some of their add-ins and where they're located. So under the Tools menu, this is where you'll find SolidWorks. They've moved some of the Express products to different locations, but you will find it under the Tools menu. There's where we can get access to things like the component library or just opening up an ECAD file. In this particular case, I have version 1 of a cell phone PCB file coming in from the ECAD group. They exported it out of, let's say, OrCAD or PADS. And when I open up the cell phone PCB, it opens up SolidWorks. Now, SolidWorks runs as its own window that can be resized so that you can see SolidWorks in behind it, or split the screen so you can see SolidWorks directly. What you're going to get is something very similar to what we have in SolidWorks, where you have multiple tabs at the top that organize commands that are specific to the circuit board. And then you'll get a tree that lists all the things that will be imported as part of this circuit board design. Now, if I go through this tree a little bit, if I expand components, I can see that there's 549 components. The ones with the little asterisk, the orange dot on it, tells me that this particular component is not located in the library currently, that the software is going to have to build this. I can get to each individual component if I like to, and even go as far as looking at the properties of each individual component. I can see the part number, the reference designator. Is this an ECAD or MCAD file? Whose ownership? What side of the board or what layer on the board is it in its location? X, Y, and Z. So I have some nice tools to do that. On top of that, you can see the graphics area looks a little bit cluttered. I have the ability to start to turn on and off things within the graphics area. One thing I like to do is turn off my reference designator so it doesn't cover all of my individual components. And you'll notice that as I make selections from the component tree, that it does show you where those components are. I also have the ability to view both the top and the bottom of the board just by hitting this preview screen to view top and bottom. If I wanted to zoom to areas, they have zoom tools built in here. So let's say I wanted to zoom to a particular area. It uses the same kind of zooming capability that you have in SolidWorks. So roll your wheel away or roll it towards you to view various areas within the software. So we have several components that are going to have to be built as part of this process. If I go down a little further, you can see that there's a triangle exclamation point on this buzzer here. Now if I go to the properties of the buzzer, I can see again the part number information associated with that, the location. It does tell me where that buzzer is going to be located. But it also gives me one other important piece of information. If I go to the properties of this folder, which is the buzzer folder here, you can see here where the outline is. It tells me where the SolidWorks file is that it's going to use in the library if it has to. But the reason why I have an exclamation point is because it doesn't have any information coming from the ECAD system that says the height of that component off the board. So you'll see these exclamation points. The ECAD group that you're currently working with in your organizations, they would need to get into the habit of putting Z height information in their component library. Now they do a lot of what we do inside of SolidWorks when we go to populate assemblies. They have a library of components that they're adding to boards, and this just gives them the ability to add that Z height information. Or when it comes to the MCAD group through SolidWorks, I can add the Z height information as I choose to. I also have the ability, if I wanted to, and go to the properties, is to modify the reference designator if I'd like to. So this is buzzer 301. I can call this buzzer 304 and make a change to it if I turn on my designators. You can see that I do have some capabilities of making some modifications even before I import it into the SolidWorks end. Another set of tools that I like to deal with, and it will be helpful for you when it comes to building the board in SolidWorks, there are times where you're just looking to bring in the top largest components in the SolidWorks so you can avoid them. You can see there's a lot of components on this board. I may not need all of them. So I can just say, you know what, filter out everything above 2 millimeters. Okay, I can use that as a filter tool. And if I look at the component tree now, you can see that it's shut off several components. See how they're grayed out here? It's almost like suppressing them. But watch as I kind of drag this slider bar here further to the right. What this is going to do is turn on and off different components that are taller or smaller than a particular size. So I'm basically telling the software everything taller than this number, get rid of. Converse to that, I can say everything shorter than this number, get rid of. So I can clearly see, okay, here's all my components above 5 millimeters on the board. Maybe that's not enough. We want to go a little smaller. We'll go down to 3 and see what we have available to us. So still not a lot of components. Let's go down to 2. And we've got a few more. Let's go down to 1. And that looks pretty good to me. So filtering is a nice way to say, I really don't, in my case, need to have all this information in there. Maybe you do. It'd be great too, because we'd have accurate bill of materials. But a way of filtering out that information. And in my case, I'm not going to filter that out. Now, the library itself is also accessible in here. We're going to talk a little bit more about the library when we get into the SolidWorks, but you can get access to the library inside of CircuitWorks as well. From here, once I have everything set the way I want, I filter out the components that I want, I just tell the software I'm ready to build the model. I'm just going to make this a little bit smaller so we can kind of watch what happens here. It tells me in this case that I have 7 components that don't have height associated with them. Now, what happens is it still brings them in. It just brings them in as 2D sketches. If there's an existing board within the database or existing models, I can tell it to use the existing models along the way. Now it's just going to go through and it's going to confirm that everything gets created, and it's going to build the board inside of SolidWorks. All the while it's going into the library, confirming that the part exists or doesn't exist, and even gives you a component count of where it's at 35 of 79 in this case. Again, what we're trying to do is just get an accurate board inside of SolidWorks so that we can do some work. Now, our conversation initially started about the communication, and there really is no communication if you can't make changes and talk backwards to your ECAD group. Okay, so as it finishes this board here, you'll notice that I now have access to all the components, all the notes, everything that I had inside the preview has now been built inside the SolidWorks model. You will have a full assembly with all the components being individual components within it. There will also be another tab for CircuitWorks that allows you to get access to each of the individual components, the component properties. It allows you to get information to the different things that you've imported into the system, very similar to the tree that we were just seeing inside the CircuitWorks preview. When we talk about the library is built as you're bringing in board files. And as I said, if a file doesn't exist in the database, it actually just extrudes the footprint of the component to a height, to a Z height. But any of these components here, as you can see, that have part numbers and names, I can actually edit the component or open the component in SolidWorks and actually make more detailed models. And let me just kind of flip through some of these, see if I can find one that's a little more detailed. It doesn't necessarily have to be just a rectangular circle that's extruded. you can go in there and make models that are much, much more realistic after the fact. And you kind of build this library. Look at this, resistors that have the bands on them, which is kind of nice. If I wanted to, I could at any point edit a component, which would allow me just to browse to a new file. Maybe you've downloaded the component. The backbone behind SolidWorks really is the library. This library gets built over time. Although it gets automated, the building of it is automated when you bring files into SolidWorks. So what about changes? So I'm a mechanical guy. I'm looking at this thing. I see that I have an issue. I need to slide a component around. I'll go ahead and move that component. Maybe I need to slide this component a little bit. Maybe I want to edit the physical board outline itself. So maybe I'll open up the board here, go to the outline of the board. We'll make some modifications here, and I'm just going to add some stuff to it here. Just something that will be fairly obvious. Let's see here. And we'll go ahead and trim this away. Feels like trim gets further away every time I go to find it here. All right, so we'll go ahead and get rid of a few things here and just exit the board. Go back to my assembly. Now I've made some changes mechanically because I can adjust the board. I want to re-communicate these changes back to the ECAD folks. Well, inside of SolidWorks, first thing I want to do is export it to SolidWorks. When I export it to SolidWorks, okay, you're going to see here in just a moment, it's going to now, with the old file still open, it's going to now do an analysis, a comparison between the original board and the new board that we had. Let's turn off the reference designators here. But it gives me a little bit of an idea as to what changes have occurred between the two files. That's done through a tool called Compare. So once I now have both of the files open, I can tell the software to compare those. And you can see right down here, the compare window, it tells me that this component, B300, has been moved by this distance. This board shape has changed, and this component has moved. So I can clearly see, even in the intermediary between mechanical and electrical, that there is a difference here. In this case now, when I'm ready to take this back to the ECAD, all I have to do is perform a save as and save it out in the file format that we use to bring it in this case, an IDF format. Okay. So it's very easy to go back and forth between the systems. I'm just going to close some of these out here. Now what happens when there's a change, again another change to the file, and let's close this. Alright, I'm just going to save this assembly here. Let's say now we have this inside of SolidWorks, we put it in our assembly, we're using it on our bill of materials, we have all our components and our packaging built in there. What happens when we get the new version of the board design with new components? When you go ahead and open up, let's say, version 2 of this file, you have the ability, again, to see what's coming in, see what's missing. But when you tell it to build the model and the assembly is available, it says, hey, this assembly is open. Would you like to list the differences between this new version of the ECAD file and the assembly that you have open? Okay, I'll go ahead and allow the software to go ahead and do that. Now, what it's doing here is it's scanning the model for changes. So again, two different ECAD files coming back and forth. It's able to understand when components have been added, moved, or changed. Okay, and here's the list of changes that you have here. Now let me show you this first of all. Notice in here we have D200, D201, D202. If I go to the SolidWorks version, you can see that there has been no update as of yet, right? So I'm still working off the original board import that I had when we first started. What I will have the ability down here, if I were to right-click on any of these changes, is I can actually apply these selected changes. I can do this by shift selecting each of them or applying them one at a time. It even tells me when components have been removed, when the board shape has changed. Again, the board shape is changed along the way. What it's essentially doing here is allowing me to make those changes inside of SolidWorks by just accepting those changes in CircuitWorks. So the comparison tool is very nice. It's going to go ahead and update components and give me some information about what we're capable of doing here. Okay, let me finish accepting my changes, and then I'll show you the SolidWorks model along the way. All right. So when we now go to SolidWorks, you'll see that the new components have been added to the system here. Okay, so this is the way we can go back and forth between the two. Now I want to show you a little bit more complex model. Let me close down the file within CircuitWorks here, because the support goes much further than what I showed earlier. This is a PADS file format. The .asc file comes from PADS. If I open this up, CircuitWorks supports not only your board and board outlines and cutouts, but the layers in your board itself. So the component side, the power and ground layers that you may have in a multi-layer board. It understands the plated holes and non-plated holes. Then here's where it gets nice. You get to deal with traces. So as I grab a trace, I can see them highlight in red in the graphics area. I can filter traces. I can also see pads and filter pads as well. And then any vias that I might have are also listed here. So it supports all of these things. If I were to build this model, I'm going to go ahead and do this. It has to build 206 pads and 190 traces. This will take just a second, but I want to show you what that looks like coming into SolidWorks. Because you have all this data in the original ECAD file, you'll get some really nice looking boards with a nice bit of accuracy. I think this is a multi-body. Yeah, let's hide you. So here's what you might get looking inside of SolidWorks once you get all that data out of the ECAD system. Two other things I wanted to talk about before we close. I want to talk about how you might start the process. I mentioned the fact that you can start with a complex board design, and I'm just going to do this in a part file here. Let's say I wanted to start in SolidWorks with my own board design. I might come in here and create my board and dimension it and start to add all the other things to my board that I would typically want here. Let's say this is going to have some cutout in the center here. Let's add all my fillets. All right. Never accepted those. Let's go ahead and add this. So I'll create the original outline, go ahead and extrude it. Okay, I might add some other things to it. I want to create a new sketch. We'll put some plated holes or non-plated holes as separate features here. I'm just going to add a couple. You'll get the point here. Now, the way that the system works is that it needs to see features named a certain way for it to recognize it as a feature of SolidWorks. Now, SolidWorks makes it easy to do, however. I'm just going to create another solid body over here. We'll go ahead and extrude that, but I'm going to turn off merge result. This is going to be an area that we keep away from within the board. Now, once we have the board design, I know it can be a lot more complex than this, but I build this inside my SolidWorks model. I can go ahead and perform an export to SolidWorks. And notice how it's saying, hey, what kind of object am I exporting at this point? Is it a board, is it electrical or mechanical component? Is it part of the SolidWorks process? First thing it wants to know is the top of the board. That way when it goes to place components, it understands what is the top of the board. What is the board outline? And it can use a sketch. Now typically, if I just name the sketch board outline, it would go ahead and grab that. But since I didn't do that, I can actually select it as the feature. And notice what it's going to do is it's going to give it a new name and call it board outline. So you use this export wizard and it automatically renames things for you. Okay, as I go through, what are my non-plated holes? In this case, I have no non-plated holes. My plated holes, we'll go ahead and select my cut features. Notice it's going to rename the feature PTH because that's the terminology that it used. And now we can start to represent other types of areas. Keep out areas for holes, keep out areas for components and traces and test areas. I'm just going to use a component keep out area, and I'm going to select the multi-body here. And again, look what it does. It renames the boss extrude so that I know exactly, so the SolidWorks knows exactly what it is when I get to the other end. When I hit finish on this, you'll notice here that this is going to go right into SolidWorks. In just a moment. All right, let's close this. Hopefully I can get this closed down and get that board open. Well, the board will export into SolidWorks, and then I can save that as an IDF file and give it to the ECAD group. And I think because I had the board open, it's squawking at me here, but it gives me the ability to start the process inside of SolidWorks, and really that's the important part. For those of you designing, devices, handheld type devices, anything with a circuit board where you want to make a different kind of circuit board, but you want to start the process. This is a great way to start that and go back and forth between the two. I'm just going to close these down here for a moment because I want to talk to you about kind of the future. And the future, well, I'm saying the future now, but it's already changed. IDF has been a format that's been used pretty widely throughout the years, and IDF4 came out with support for all these other things that you just saw, like traces and all these complex shapes that we're talking about. But another format in the last 3 years has really stepped up. It's a format called ProStep, and there's a lot of ECAD vendors that are supporting it. And of course, when they support it, we support it. And we started our support in 2012, and it's only been enhanced. And I found a good video that shows the relationship and the back and forth between the two. But ProStep was developed kind of like IGES is that, a group got together and said, we need another format that we can all work with that will allow us to communicate back and forth with each other. And the ProStep format allows for a lot easier incremental changes and communication between the two groups. So I want to just show you this. This is a video from 2012, but I think this will show you what I'm talking about.
Second one, 2012. Now supports the new ProStep EDMD format. Many of the top electrical vendors like Mentor, Cadence and Zuken support ProStep. This format is now rivaling and in many applications overtaking the use of IDF. ProStep support in SolidWorks 2012 promotes a higher level of communication between electrical CAD and mechanical CAD users. With ProStep EDMD, all changes are captured and incrementally communicated to ensure that both mechanical and electrical teams are working concurrently in the most effective manner. This battery charger has been designed by the mechanical team, and I want to send over the base design of the circuit board to the electrical team to finish off. Using the new EDMD option in SolidWorks 2012, the board is synced to create a baseline for this design, and a message can be sent to the electrical team so they fully understand the job in hand. As an electrical engineer, you turn on the EDMD tool and simply pick up the baseline file for the new job. This includes both the design and the message from the mechanical team. All components and holes are listed in the table and can be accepted or rejected with more options for communicating your decisions. Within seconds, the new circuit board design is ready to be worked on in the electrical system. The next step is to add the components to the circuit board so that this charger will work. From the electrical CAD library, the components are populated onto the board. Once these components have been added, these incremental changes can be sent back to the mechanical team for review. All new components are listed in a table, allowing the electrical engineer to choose what changes are passed across. Along with these changes, messages can also be sent, enhancing the communication and allowing all parties to understand what has just been done. Back in SolidWorks, we are notified automatically that changes have occurred. Here we can review each change and component that has been added to the board. SolidWorks animates these changes to help understand what has just been done. And again, just like in the electrical CAD system, you can accept or reject these changes, communicating back to the electrical team. Once I'm happy, I can ask SolidWorks to automatically build the board and add the new changes to the design. Again, communication with the electrical team is possible to let them know what we think about the changes that have been added. In this case, this looks okay, but I want to check the design again. As with all design work, new ideas and unforeseen situations arise. A request has come in to make the batteries easier to remove. A thumb hole is required that could have an effect on the circuit board. Clearly, the electrical components as they are won't work. We could go back to the electrical team with the updated board, including the hole. However, in using 3D CAD, we're in a great position to change the design right here. Repositioning these in SolidWorks is easy. I can even check that they don't cause any problems with other components in the assembly. Collision or interference detection is a great asset with designs like this. All I need to do now is send the new changes back to the electrical team and ask them if the changes are okay. Communication between electrical and mechanical engineers has been greatly improved, allowing you to make decisions quicker and without error. SolidWorks 2012 removes the barrier between design teams and allows you to get your products to market faster. SolidWorks 2012 now supports the new ProStep ED.
Alright, so as you can see, this ProStep format that's kind of taken prevalence in the industry kind of has some more built-in functionality to communicate a little better or differently, or even compare changes and do some live edits. So, I would say that if you have an ECAD group and you can try the various formats, IDF4 being the latest IDF that has all the support for the multiple items, and then ProStep is probably going to be the next one in line that you're going to want to look at. So if you're looking for the little bit more information on the two, If you just go to SolidWorks.com and search for CircuitWorks, you'll see just search on IDF actually. You'll find a lot of information on IDF files and CircuitWorks. Everybody has CircuitWorks Lite, so if you have an IDF file, or if you want me to send you one, I'll be glad to send you an IDF file that you can use to show your colleagues how you can import circuit board designs. And just remember now that your CircuitWorks is included in SolidWorks Professional. So I want to thank everyone for their time today. Hope you learned something from this and get to use CircuitWorks. Have a great day.